Okay, Algebra 2, welcome to the Quarter 2 benchmark assessment corrections. We're going to start right away with number 1. So when converting exponents out of fractions, there's two major rules that you have to remember. The top number stays on the inside of the radical, and the bottom number stays on the outside of the radical. So with those two rules in place, the correct answer is actually number 1. Okay? Actually, let me get my drawing tool out. Sorry about that. Number 1. Number 2, the accompanying table defines functions f and g. So I know that this is f because f of x is here, and this is g because it's g of x is here. Oops, sorry about that. So what is g of f of 3? So when I rewrite that, okay, so that would be g of f of 3. Okay, and remember that you have to go inside to out. So I have to find f of 3 first to then find g of whatever this number is. So if I go to f of 3, when I go to 3, my answer here is 5, okay? So g of 5 is actually equal to what? So when I go here to 5, my answer is 8, okay? So this answer here, ladies and gents, for number 2, answer 8, which is number 3. Whoa. Yep, 2 is 3. Yep. Just making sure that's correct. What threw me off is what probably throws some of you guys off is seeing the f of x and the g of x and like the y. But f is the function that defines this table. F of x just means these are my y values for the function that is f. That might not make sense. If that's not clear for you, please follow up, okay? But yes, the correct answer here was 3. Number 3, it says the expression x minus 6 squared is equivalent to. So remember, because this exponent is here, this is not the answer. So a lot of you guys are quick to write that, and that's not correct. We went over this in class. This means that this expression is multiplying by itself 2 times. So then we complete FOIL. So x with x times x with negative 6, negative 6 with x, and negative 6 with negative 6 times negative 6, okay? So you should get x squared, negative 6x, negative 6x, and 36. And because these two are like terms, I get negative 12x. So ultimately, what it should get is x squared minus 12x plus 36. And I do believe that that matches with answer choice number 3. And just to check, yes, number 3 is correct. Now, number 4, the table shows the number of grams of carbs and the number of calories in 6 different foods. So here's my x and here's my y. Which equation best represents the line of best fit for this set of data? So we definitely saw growth in how you guys answered a question like this. I went ahead and I populated these numbers into the Desmos linear regression calculator. And basically, like your calculator would, I put all my x values in and all my y values in, and I made sure that every domain had a range. And so here is my information, right? So I know that my b is 5.8, and I know that my m is 14.1. So after doing all those calculations, I get the right answer on the calculator, which in this case is number 4. Okay. Here, I used, so I'm gonna close that tab. Yep, we can leave, it's time to go. So for this question, this was another question that was calculator heavy, right? So for this function, it can be used to predict the temperature of a cup of hot chocolate in degrees, right? So what is the approximate average rate of change? Average rate of change is like the big thing that you got to be focusing on. When you see the words average rate of change, you should automatically be writing the average rate of change formula, which we all can like say in class, but I think that when it comes to testing, You guys are still getting really confused. Also here, because it's two brackets, I know that I have an x1 here and an x2 here. So you have to plug in these values individually into this function to get their y values. So step one is to find the y's, find the y1 and y2. And then the second step is to find the average rate of change, AROC. Okay, so I pre-populated those numbers again for you guys. So I'm plugging in 0 for the first one, getting that number, that's my y1. Plugging this x2 in right here, that would be my y2. So boom, that's what I did here. I plugged it in, plugged in 0, I got 159. Plugged in 6, I got a number that is continuous. It's a decimal. But then I went ahead and did, so remember, this is my x1 that I plugged in right here, and this is my y1. This is my x2, so then I got my y2. Remember that the formula is y2 minus y1, so that's why I have 105 point whatever. I literally just copy and pasted it here, minus this over 6 minus 0, and you should get negative 8.93, blah, blah, blah. Okay, so going back to this, your answer here should have been 1. Okay. 6 was interesting. I was really excited to see how you guys would do with that, but only 39% of you got it right, even though it was the majority. So it says which expression is not equivalent to this, and you kind of have to remember all the rules of log. So if a log can exist like this, that means that the number in the front can also exist as an exponent. So to rewrite this, I could write log base b is equal to 2 to the 6. If I have addition and my bases are the same, that means they're essentially multiplying. So this would be log base b to the 9 times 4. Okay. Same thing here. If this number can exist out in the front, that means it can also exist as an exponent. So I have log base b to the 6 to the second power. And then again here, since my bases are the same and they're subtracting, I know that these two are dividing. So I can rewrite it as log base b 72 divided by 2. Now, these are not simplified, so I'm going to go right ahead and do that. So if you use your calculator, 2 to the 6 is actually equal to 64. So this is log base b 64. 9 times 4 is 36. So this would be log base b 36. 6 squared is 36. So again, this is log base b 36. And then 72 divided by 2 is 36. So it's log base b 36. Now the question's asking which one's not equivalent, and the answer is obviously 1. Okay. For number 7, I also pre-populated in the Desmos calculator. So which sketch could represent this function? So literally all you had to do was take this information right here and graph it on your calculator, and whichever image was the closest is the one that would be your answer. So I did that for you guys here. Negative 100 to the x minus 2. Just want to, log base 100. Oops, gotta fix this up for y'all. Please hold. Here we go. Functions. Here we go. So that's base 100. It's actually really good for you guys to see that honest mistake happens. Okay, so it's negative log base 100 to the x times 2, which is good. All right, boom. So here in the calculator, I see that the function is more or less in my first and fourth quadrant. If I zoom out a little bit, this is kind of like what I'm getting. I want to see it big on the x and y axis. Okay, so if I go ahead and what number is this? 7, right? So the one that is like kind of like in these two axes. So it's clearly not number 1, and it's facing, it looks like it's going from top like down like this, right? So it's got to be something that kind of looks the same. And what I would pick is actually answer choice number 4. Okay. Because it's going top down, it's not circling up like this, and it's not facing that direction. That turning point is over by the x-axis, not like that. So the answer is 4 for number 7. Robbie's working on one side of a polynomial identity proof, use blah, 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 blah. So this verbiage in this question was meant to throw you guys off, but this is not about Pythagorean theorem. It's about how you simplify. So here, if I have 5x squared, that means I have 5x times 5x plus. Again, this is squared, so it's these two again. 5x squared minus 5 times 5x squared minus 5. Okay? Now I have to go ahead and multiply that through. So 5x times 5x is 25x squared. And then I got to go right ahead and FOIL this out, but matter of fact, I'm just going to do it. So then here, I'm going to do the extra work up here, right? Because it's 5x squared times 5x squared. So actually, let me move this up like so. So that's going to be 5x squared times 5x squared, which is 25x to the 4th. Then 5x squared times negative 5. Negative 5 times 5x squared. And negative 5 times negative 5. So this would give me negative 25x squared. This would give me negative 25, right here, x squared. And this would give me positive 25. Now remember that these two are like terms, so that gives me negative 50. So essentially what I have here is plus 25x to the 4th minus 50x squared plus 25. So kind of pausing and looking at step 1, right? So it looked like Robbie, step 1, he multiplied these two, and that's good so far. And then he kind of left this alone, which means that he wanted to simplify after, boom. So kept this number here, but on the next step, he had this, which is not this. He didn't FOIL correctly, okay? Now, when you get to this step, you're supposed to combine 25x squared minus 50x. So you get 25x to the 4th minus 25x squared plus 25. That should be your final answer. But let's look at what's happening here. So going with the work that he had, he combines this and this, 50x squared plus 25, which is technically correct. That step is correct for the incorrect work. But then here they got 75x squared, and that's not correct because these two are not like terms. So kind of keeping in mind with what we've analyzed, right? There is a mistake here and there is a mistake here, and that is in step 2 and step 4. So the correct answer for this question is actually 3. Okay. Consider the function h of x. Which equation could be used to represent the graph below? So we kind of like, when we did this topic in class, you guys killed it. For some reason on the test, you guys are drawing blanks. Only 44% of you answered this correctly, which is quite alarming. But this is a reflection over the x-axis. So that means that, let me see on here. That means that the, remember, if it's on the inside, like say, so if I have h of x, right? And I wanted it to flip this way, right? That's on the y-axis. So that means that that reflection would be h to the negative x. But since it flipped over the x-axis and it went down this way, that means that my negative is on the outside, okay? So this is for, again, this is for a y-axis reflection, and this is for an x-axis reflection. So the correct answer to number 9 was 3, okay? I have to check if a lot of you guys chose this one instead, but there was no shifting that happened, so you should not have picked one and two.